This is Calculus 2 class. Today we are going to begin with important application of integral, arc length, and the surface area of revolution. First, we will learn how to find length of curve using the arc length formula. This extends the distance formula we already know into calculus, letting us measure curve with exact precision. Second, set up the evaluate surface area integral. By rotating curve around the axis, we can find the surface area of 3D solid that's created. Finally, we will apply both techniques to real example so we can see how arc length and surface area connect geometry, calculus, and your world problem. Let me ask, how far is it from Houston to Dallas, guys? Houston to Dallas, how far is it? The simplest idea is you draw the straight line by using the Pythagorean theorem or distance formula. We can calculate straight line distance. But here's a problem, guys. The road isn't straight. When you actually drive, the road bends and curves, which makes the real distance longer. So we need a new tool that goes beyond straight line geometry. That's where calculus and arc length formula comes in. Here is a curve from the A and B. The measure its length. Let's start an approximation. So I divide interval of A and B, make a small subinterval, and place some point along the curve. A go to P0, X1 go to P1, point on the curve, X2 is P2, and keep going. Xi minus 1 gonna be Pi minus 1, Xi is Pi, last point gonna be B, that's gonna be Pn. So this, I put a few points along the curve, connected them tiny segment. Let's say P0 and P1. See that? Tiny line segment between each point. Each segment can be measured using the distance formula, which comes from Pythagorean theorem. Then we're gonna add all together of this segment of length. We get estimate for the length of the curve. Now, of course, if you only use a few segments, the estimate is low. But as you add more and more points, making each segment shorter and closer to the curve, our approximate improves. How gonna derive formula for arc length of curve? So previous slide, we saw the tiny line segment, guys. So if you find the distance of tiny line segment, we can find arc length of curve. So absolute value Pi minus Pi, that's gonna be distance of tiny length. So I'm gonna put that's gonna be delta S. So delta S, we have find it. So I sketch right triangle from the curve. Pi minus 1 is right there. Pi, we wanna find distance between 2 points. The base gonna be delta x, height gonna be delta y. How gonna find the delta s, distance between 2 points? We can use Pythagorean theorem. Delta s equals square root delta x squared plus delta y squared. I'm gonna plug in back into this length of arc, we have limit summation square root delta x square plus delta y square. Now, I'm going to take out delta x square. Now we have limit summation square root 1 plus delta x square over delta x square, delta x square. So square root delta x square is delta x, delta y square over delta x square put together, delta y over delta x square. So we have limit summation integral 1 plus delta y over delta x square delta x. Now, this limit summation fall into the integral form. Now have integral a and b square root 1 plus dy dx dx. dy dx meaning is f prime x first derivative. Also, limit summation delta s, we gonna write the integral rotation gonna be integral ds. Now, the formula for arc length with respect to dx gonna be now L is integral dx, so integral a and b square root 1 plus dy dx square dx. Now, we derived the arc length formula. Let's just summarize the two cases. First, if we have curve y equal fx, that case we have to integral with respect to dx. So y equal f of x, we want to find arc length between the a and b. Then we're gonna use this integral formula right here. Integral a and b square root 1 plus f prime x square dx. This one is we're gonna use integral with respect to dx. But if the curve is written as x equals gy case, then we have to use the integral with respect to dy. So this time, graph gonna be x equals gy. We wanna find arc length from C and D. That case, we using this formula, length of arc, integral C and D, square root 1 plus g prime y square dy. So make sure which one you're gonna use. But both comes from exactly same distance formula, but choice depends on which variable make integral simpler. Let's look at our first example. The curve defined by y squared equal x cubed for x is between 1 and 4. We want to compute arc length using dx. So we have to use this formula. dy equals square root 1 plus dy over dx square dx. We need to find dy dx. Another way we say y prime. Before you find the derivative, we have to solve for y. So y squared equal x cubed, meaning is y equal x to 3 over 2. So take derivative with respect to x. That's going to be dy dx. Power is coming down 3 over 2. X 3 over 2 minus 1. 1 over 2. Power is 1 over 2, meaning is square root of x. Now, we can compute arc length by using the formula right here. So L gonna be, what is the interval of x? 1x equal 1x equal 4 square root 1 plus dy over dx square dx. Guys, right there. dy dx y prime gonna be 3 over 2 square root x. When you square 3 over 2 square root x gonna be 9 over 4x. That's you have it. So now we need to evaluate this integration. We should use what? U gonna be 1 plus 9 over 4x. Du gonna be 9 over 4 dx. dx gonna be 4 over 9 du. You also substitute lower limit, upper limit. So x equal 1. U gonna be 13 over 4. X equal 4. U gonna be 10. So now arc length should be integral 13 over 4 to 10 square root to y 4 over 9 du. I'm going to take out 4 over 9 in front of integration. 4 over 9 integral 13 over 4 to the 10 square root to u du. So we can find antiderivative square root to u. That's going to be 3 over 2 u to the 3 over 2 du. I'm sorry guys, 2 over 3 u to the 3 over 2. That's you find it from x equals 13 over 4 to the x equals 10. Let's just simplify in front, guys. You have simplified this term. 4 times 2 is 8. 9 times 3 going to be 27. So you have 8 over 27. Now you plug in u equal 10. 10 square root to 10. U equals 13 over 4. 13 over 4 square root to 13 over 4. So we want to simplify 13 over 4 square root to 13 over 4. That's going to be, guys, that's going to be separate square root 2 here. Square root to 13 over 2. 4 times 2 is 8. So now we have 8 over 27, 10 square root to 10 minus 13 square root to 13 over 8. Distribute 8, both terms, you have 1 over 27, 8 square root to 10 minus 13 square root to 13. Let's have one more example. This time curve gonna be y equal ln secant x between x is 0 and pi over 4. So we're gonna use arc formula with respect to dx this time too, guys, okay? So first one is gonna be arc length formula gonna be integral ds. ds gonna be, we're gonna use the formula with respect to dx. That's gonna be square root to 1 plus dy dx square dx. First you have find dy dx, y prime. What is y prime? ln secant x, dy dx gonna be, derivative ln gonna be 1 over secant x, derivative secant x gonna be secant x tangent x. Secant x gonna be cancel out here, guys. Secant x gonna be cancel out. Right here, secant x cancel out. That's we have tangent x. So now arc length gonna be integral, interval of x gonna be 0 and pi over 4 square root 1 plus tangent square x. 1 plus tangent square x gonna be secant square x. You plug in back, integral 0 and pi over 4 square root secant square x dx. Square root and square gonna be secant x. So integral 0 and pi over 4 secant x dx. Antiderivative secant x gonna be ln secant x plus tangent x plus c. So now we can evaluate this integration. ln secant x plus tangent x from x equals 0, x equals pi over 4. When you plug in x equals pi over 4, secant pi over 4 is square root 2, tangent pi over 4 is 1, x equals 0, secant 0 is 1, tangent 0 is 0. So we have this value, ln square root 2 plus 1 minus ln 1. ln 1 is 0, guys. ln 1 is 0. Arc length should be ln square root 2 plus 1. Now, we have another example. This example we want to do with respect to dy. Why? Look at this one. This parabola that open to the right. So since it is naturally written as in terms of y, we should use the arc length formula with respect to y, which meaning is we have to solve this curve for x. That's the idea, guys, okay? So this one is we want to find arc length here, red part, right here, guys, this one. But this one looks like open to the right. So we want to solve for x. So using this formula, ds gonna be square root 1 plus dx over dy squared dy. Use the arc length formula with respect to dy. So first thing is we have to solve for x. X gonna be y squared over 2. So dx dy gonna be y. 2y over 2 gonna be y. Okay? Now, plug in the dx dy into the formula. So L gonna be, here's very careful, guys. Here is, this one is, we're gonna use arc length formula with respect dy. So we need to write the interval of y. Interval of y is 0 and 1. 0 and 1. Square root 1 plus y, the x prime. X prime gonna be y. That's the y squared dy. Guys, make sense? So we want to evaluate this. How gonna evaluate? Which integral technique we should use? We use trigonometric substitution. So y gonna be tangent theta. So dy gonna be secant square theta d theta. Upper bound, lower bound, you have find it. So that's gonna be y equals 0 is bottom. Lower limit, tangent theta is 0, theta gonna be 0. Upper limit, y equals 1, tangent theta is 1, theta gonna be pi over 4. So now substitute everything for the disintegration. Integral 0 and pi over 4 square root y gonna be tangent theta 1 plus tangent square theta. Dy gonna be secant square theta d theta. What is 1 plus tangent square theta? That's the secant square theta. So we have integral 0 and pi over 4 square root to secant square theta gonna be secant theta, secant square theta d theta. That's gonna be secant cube theta d theta. We have this integration, integral 0 and pi over 4, secant cube theta d theta. How gonna evaluate integral 0 and pi over 4 secant cube theta d theta? We should use integration by part. Here is antiderivative secant cube theta d theta, guys. Integral secant cube theta d theta gonna be 1.5 secant theta tangent theta plus ln secant theta plus tangent theta plus c. Now, guys, so evaluate this antiderivative from 0 and pi over 4. When you plug in pi over 4, that's going to be secant pi over 4 square root 2. Tangent pi over 4 is 1. Then x equals 0, secant 0 is 1, tangent 0 is 0. So when you plug in this value, 1.5, square root 2 times 1 is square root 2. ln square root 2 plus 1 minus 1 times 0 is 0, ln 1 is 0. So we have arc length for this curve right here. 1.5 square root 2 plus ln square root 2 plus 1. Now, Let's extend the idea of arc length to the surface. If we take a curve and rotate it around axis of x-axis, it creates solid of revolution like one shown here, guys. But outside of this solid, we call surface. To calculate this area, you zoom in one tiny piece of curve. So look at this small piece, small arc is pi minus 1. Pi minus 1 pi. This one is rotated. It sweep out a thin cylindrical strip right there. So we want to find this surface area, guys. We want to find the surface area right there. So entire surface is really made up of many thin cylindrical strips formed by tiny arc of curve. So that's we're going to find surface area at all surface of tiny cylindrical strip. That's we're gonna derive formula for surface area of revolution. Let's look carefully at just one tiny arc of curve pi minus 1 and pi. Pi minus 1 pi. When the small piece rotates around the x-axis, it sweeps out the thin cylindrical strip. So how gonna find the surface area about this, guys? So we want to find area of thin cylindrical strip. So this one is, the first one is you haven't find the radius circumference. Radius gonna be yi, that meaning is fxi. The circumference of that one is 2 pi xi. Now, then we have length of strip, that's the arc elements at delta si. You have times it, that's the surface area of thin cylindrical strip. So you have delta Si equal 2 pi fxi delta Si. This Si is length of arc. Here is right there. This capital S gonna be surface area of cylindrical strip. So we want to find whole surface. So we cannot stop with one strip, right? Sorry. We need to add up all up to along the curve. That mean is, guys, you have to add all of them. So summation 2 pi fxi delta I. Now we take a limit. As those strips get infinitely thin, that sum's gonna be into the integration a and b 2 pi fx ds. Okay, guys? Make sure is ds, that's the length of arc length. This is with respect dx, that gonna be square root 1 plus dy dx square dx. Surface area gonna be a and b 2 pi f of x square root 1 plus dy dx square dx. dy dx gonna be f prime x. That's we have formula for surface area of revolution about x-axis. Previous slides, we derive surface area formula with respect to dx. Just like arc length, surface area also has two useful forms. First, if curve is written as y equal f of x, guys, y equal f of x, and rotated about x-axis. So with that case, we have integral 2 pi radius ds, radius gonna be f of x. The ds gonna be square root 1 plus f prime x squared dx. Interval gonna be x, a, and b. That's what we have for surface area. Second, another form of formula gonna be function is x equals to y and rotated about the y-axis. We have to switch the variable. The variable switch. Surface area formula same, integral 2 pi radius ds, but radius is changed, ds gonna be changed. This time we're gonna use variable y. So we have integral c and the interval of y, 2 pi gy square root 1 plus g prime y squared dy, guys. So both formula comes from the same idea. Each tiny arc sweep out a thin cylindrical strip. Integrating those strips gives the full surface area. Let's first example for area of surface. First, guys, thinking about function y equals square root of 4 minus x squared. That's the curve. We're gonna rotate this curve over the x-axis from -1 and 1. So this one is rotated x-axis, y equal fx form, so we have to use surface formula. Looks like this one, guys. Radius gonna be f of x, radius right there. That's the y value. So radius gonna be y equals square root 4 minus x squared. ds, arc length gonna be square root 1 plus dy dx squared dx, because that's rotated x-axis. Function gonna be y equal f of x. So we need to find the dy dx, derivative of y first. We have to using chain rule. Power is 1/2. So 1/2 is bring it down. 1 over square root 4 minus x squared, derivative 4 minus x squared gonna be negative 2x. So cancel out 2, negative x over square root 4 minus x squared. Let's find the ds first, guys. ds gonna be square root 1 plus dy dx squared. So negative x square root 4 minus x squared, square gonna be, what is it, guys? What is it gonna be? X squared 4 minus x squared. So I want to simplify inside the square root. So that's the same denominator, 4 minus x squared. Numerator going to be 4 minus x squared plus x squared. Cancel out x squared. Square root of 4 is 2. Bottom is square root of 4 minus x squared. So that's why square root of 4 over 4 minus x squared, separate square root, you have 2 over square root of 4 minus x squared dx. So now you find the ds, plug in the here. So radius gonna be y equals square root of 4 minus x squared. Now what do you have, guys? So interval of x gonna be -1 and 1, 2 pi, radius is square root of 4 minus x squared, ds gonna be 2 over square root of 4 minus x squared. Cancel out the square root of 4 minus x squared. What do you have right now? Integral -1 and 1, 2 times 2 is 4 pi dx. So integral of -1 and 1 dx gonna be 2. So you have a pi. So surface area obtained by rotating y equals square root of 4 minus x squared gonna be a pi. Let's have another example. This time we have curve. We have curve y equal x squared. Then we're gonna rotate it y-axis. So what kind of formula we have to use for this area? So we have to use 2 pi radius ds. Radius gonna be this time x, right? Radius gonna be x. So we have x gonna be solve for function solve the function for x. So y equal x squared, x equals square root y. So we need to find the ds. ds gonna be with respect dy. So we have this formula, square root 1 plus dx over dy squared dy. Let's find the dx dy. You're going to take a derivative x equals square root y. That's going to be dx dy equal 1 over 2, 1 over square root y. Let's plug in this derivative into the dy, guys. dy going to be, what is dy? So dy gonna be square root 1 plus 1 over 2 square root y squared. Let's square this part, 1 over 4y. So square root 1 over 4y dy. Let's make common denominate, okay? So that's gonna be 4y plus 1 over 4y dy, separate the square root of 4y plus 1, square root of 4 is 2, square root of y is square root of y. So let's plug in the dy into this formula. So what do you have? Integral. Very careful. Interval of y. Y gonna be 1 to 4. So 1 to 4, 2 pi. Radius gonna be square root of y times the square root of 4y plus 1 to square root of y. So you cancel out 2 and 2, square root of y and y, then you have integral 1 and 4 pi square root of 4y plus 1 dy. How gonna evaluate this function, guys? What integral technique you have to use? You use u sub. What is u? U gonna be 4y plus 1, dy gonna be 4 dy, dy gonna be 1 over 4 du. Also, you substitute row limit, upper limit. So x, y equal 1 gonna be u equal 5, y equal 4 gonna be u equal gonna be 17. So integral change, pi over 4, pi gonna be, take it out in front of log, in front of integration. 1 over 4 is right there. Pi over 4, integral y equal 5, y equal 17, square root to u du. So now we're going to find the antiderivative square root to u gonna be, guys, 2 over 3, u 3 over 2 from y equal 5, y equal 17. So simplify pi over 4, 2 over 3 gonna be pi over 6, 17 square root to 7 minus 5 square root to 5. Let's wrap up with our key takeaways from this lecture. First, arc length we learned. Calculus extends the distance formula to find exact length of curve between the 2 points, guys, okay? So there are 2 formulas for the arc length. If curve is y equal f for x, formula gonna be a and b integral, the interval of x, square root 1 plus f prime x squared dx. If curve is more naturally as x equals y, you have a second formula, integral c and d, square root 1 plus g prime y squared dy. Second, we learn surface area of revolution by rotating a curve around the x-axis, y-axis. Calculus give us the exact surface area of solid that's formed. So for rotation about x-axis, we have to use the first one. Surface area 2 pi, interval of x, a and b, radius gonna be f of x square root 1 plus f prime x squared dx. If rotated y-axis, we're gonna use the second formula, 2 pi integral interval of y, c and d, gy, square root 1 plus g prime y square, guys. So arc lengths allow us to measure curves exactly. And the surface area of revolution expand this idea to 3 dimensions. Both come directly from distance formula, and both show how calculus can take a simple geometry and make it powerful enough to handle real-world problem.